This one trick can save you hours of development time, improve communication with your team, and help you get promoted. It's project mind mapping. I'm going to take you step by step through my process for scoping and designing the core logic of an AI project without writing a single line of code. Whether it's a professional gig or a personal project, this method has saved me so much time, helped me stand out at work, and open up doors to new opportunities. And for those of you who aren't working on AI projects, this method isn't just exclusive to AI. I've used it for years now to advance in my career as a backend developer. Also, make sure you stick around until the end because I'll be sharing a roadmap along with some tips on how you can become an AI engineer yourself. Many of you commented on my last video saying that you want a step-by-step guide on building a retrieval augmented generation using LangChain. This video will be the first in that series, and I'll be showing the entire process from reading a business problem to creating a chat-based LangChain application that talks to an SQL database and external APIs. The end result will be similar to Convo GPT in that video, but I'm going to take it a step further to teach you some additional concepts. This will become a huge project, and I'm going to continue to work on it as long as people keep enjoying it. So if you want more videos, make sure to like and leave a comment. To succeed as an AI engineer, or any software developer for that matter, it's not enough to master the code. You also have to learn the career game. Like it or not, office politics play a huge part in career growth. You got to make sure your work is seen, that you can communicate clearly with other teams, like the front-end team, and prove that you can take on a leadership role on projects. Luckily, I found a technique that makes this easy: mind maps. Whenever I get assigned a new project, I will volunteer to create a mind map. Whether it's a database map for backend projects or a feature map for AI or front-end projects, this is a visualization of how all the different parts fit together and interact. And it has so many advantages. For example, visualizing everything helps you spot things that you might have missed out earlier in the planning process. It's also much easier and faster to make changes to the design rather than rewriting the code. And this is language and framework agnostic. So even if your front-end team doesn't speak Python or don't know AI, they can still understand how everything is connected and keep working without any roadblocks. And most importantly, it makes you shine. By taking initiative and owning the design of the project, it will tell people that you think outside of the box, you can kind of assume a leadership role, and you are very efficient with the time you're paid to work. And this is how you get promoted. A lot of devs get into the industry because it is fun to code, and I agree. However, nowadays, this is not enough to be an excellent developer. The communication and office politics, aka showing your work, is equally important. There are engineers out there that do far less work than you, but because of how they present it, they are paid more and are more highly valued by the organization than you are. So let me show you this method in action. Let's assume your boss comes in one day and says, "We need an AI real estate agent." You then do some research on what are the roles and the responsibilities of a real estate agent. Of course, since I was one before, I already know this. A real estate agent should show the client, aka the real estate investor, potential opportunities within their budget and desired location. They should generate reports with market data and maps with areas of interest like schools, analyze buildings, and match them with client needs. This is a good start, so let's hop on Miro and start mind mapping. Now, this is a free software that you can use to design stuff, but they have a really great and easy to use mind map feature, which I always use. So I'm just gonna delete this boilerplate stuff here. So we want an AI real estate agent, so we probably want the chat-based interface to interact with it. So at the core of everything will be the large language model. This can be, for example, OpenAI's API that we communicate with. And to talk to that, we are feeding it a prompt. Now that prompt has to be delivered from a front end. Which will be served by Flask. Now you can use a JavaScript framework here like React if you want to get really fancy. It's kind of overkill for this scope, so we're just going to use Flask, which is a very lightweight and easy way to make your Python code run on the web, essentially. So here I'm just going to click these dots to draw the relations. The Flask serves the front end. From the front end, we have the prompting. and the prompt goes to the LLM. And here's where it gets interesting. The user is trying to find properties, so we need a database with property information. Here's where you need to decide on where you're going to get the data from and what type of data that you want. If you want listing data, you can, in the US, connect to MLS APIs, but they're very difficult to get access to, or they can be expensive. In this example, just because I want to show you the AI part and not so much the real estate part, we're just going to use a database of past sales and pretend that this is like listing data or stuff that's on the market. So you can go on, for example, Kaggle and search for a real estate data set. But in this example, I'm going to use the ConoCube database, which I have a snippet that's open source on my GitHub for ConoGPT, which I'm going to link down below. So that's going to be our SQL database. Actually, I'm just going to paste in the requirements here so we have them here easily to see. Let's just look at the requirements and see how we can adjust them. So show the client, the real estate investor, potential opportunities within their budget and desired location. Okay, so the LLM will connect to the database and retrieve a result, which is actually going to come from the LLM, because the LLM is going to generate an SQL database query, get the data back, and then use that data to formulate a text-based response. So we also need to generate reports with market data and maps with areas of interest like schools. Okay, so we need reporting, which for this we're going to use the Python library Report Lab, which is an easy-to-use library for generating PDF reports in Python. And we're going to connect that like this. And that's also going to, actually we don't really, yeah. And that's also going to pipe back into the LLM, and the LLM will use that to formulate a result, or maybe a response is a better word here. And we want to generate Google Maps, right? So for that, in our front end will be, you know, of course, HTML, CSS, a little bit of JavaScript. We can use the Google Maps API. That way we can display maps directly in the front end. And similarly, sometimes we might want to visualize the data. If we get a table spat out, well, we can ask the program, hey, can you visualize the data for us? So we need a data visualization library. For this, I always use chart.js. Super easy to use, beautiful charts. So we'll have that there. Another useful feature in ConoGPT is the fact that you can prompt it to get the driving distance between 2 points. But you prompted out some of the top performing buildings, maybe you want to see the driving distance to the closest school for each building. For example, maybe you're trying to buy a home for your family. In that case, it will be very interesting to see the closest school to each building and how far you need to drive to drop off your kids there. And for this, there's a very useful Google Directions API we can use to get the driving distance between 2 points. And that's also something we'll prompt to, and it'll feed back into the LLM, and we'll get a response from that. Another component of ConoGPT is the fact that you can search for certain buildings in the database and misspell them, or you can misspell the addresses. For example, you can say 150 Northeast 2nd Avenue. Or let's say for the building called the Alexander, you instead say Axlander. It needs to be a bit more closer, I think, like that. And the software knows that this is referring to the Alexander, which is a building on Miami Beach, or that this becomes 150 Northeast 2nd Avenue. And how do we accomplish this? So what we do is we take this problem, and how we solve it is we take all addresses and building names and we vectorize the data. And when you vectorize this data, you basically turn it into a mathematical representation, which, for lack of better words, is kind of like coordinates in an n-dimensional space. And when you have these coordinates, you can calculate the similarity or the distance between two vectors. And that way you can do similarity search. So, and once we vectorize the data, we store that in a vector DB, and we can use Facebook AI similarity search to find the correct building or the correct address. And this is what we will feed into the SQL database, because we don't want to run queries on misspelled addresses or misspelled building names. So I'm just going to draw these real quick. Okay, so now I have a very basic outline, and this is actually the architecture of Convo GPT as it looks like today. These are all the features in there, and this is how they all connect together. And you can see plotting this out just makes it so much easier to see every detail. And if you architect this in the wrong way, well, it's very easy to change. You just redraw the lines or rename stuff without touching any code. So it's extremely fast. And you'll find that once you have this outline, you can write code a lot faster too, because you don't need to keep in the back of your head how everything is supposed to be laid out. You just reference this diagram. But here I actually prompted ChatGPT to give me some suggestions on how to improve this AI real estate agent and how we can learn some additional concepts. So it gave me this. For example, similarity search to recommend similar properties. Let's say the user is looking at a specific apartment in a location, and they're saying, okay, well, this is a bit too expensive. I'd like something similar, but that's a lower in price. Well, just how we use similarity search for the names and the addresses, we can use that for specific units. So let's call the problem here similar properties, just to make it easier. So here what we need to do is, the user is looking at a certain apartment. Let's say this is so it's unit 2205 in some building in Miami Beach, 2-bedroom, 2-bathroom. The price point is $450,000. So what we need to do is we need to vectorize all these attributes, even the unit number, because the unit number could contain, the floor, which in this case is that's 22nd floor. That's very important from a pricing perspective. And what we need to do is we need to vectorize this data. Now, how we do that, maybe we should use some one-hot encoding, or maybe there are some embeddings that are really good for this. We're going to explore that in a future video. But essentially, once we vectorize the data, we'll have that in a vector database, and we can mathematically represent similar apartments to each other based on how similar they are. They can be similar in terms of location, in terms of how big they are, in terms of what floor they're on, and we'll try to find the most similar apartments to this one. So we can also implement a document analysis feature, and this is extremely simple to do with LangChain and LLMs. Basically, you'll just upload a PDF, and then you'll have a template with essentially instructions on how they should parse this document. Maybe it could be an HOA document, which talks about the monthly fees for owning an apartment here and how the fees are being distributed, if it's to the pool maintenance or maintenance of pipes and stuff. But essentially here, once we upload a PDF, the software will know that it should load this template, and this template has some instructions on more or less how it should interpret the PDF. And with that, we get our response again. Another thing I want to show you guys later is data augmentation and knowledge base creation, because we're creating an AI real estate agent. This should be an expert in real estate, right? So it needs to keep up to date with news and blogs and what's happening in the market, which right now the market is Miami. So for that, we need to create a custom knowledge base that is periodically updated. And we can achieve that by, for example, attaching web scraping features to LangChain application. So we'll build and this is getting a bit messy here, so I'm just gonna move this out a little bit. Knowledge base. So the LLM should always draw from the knowledge base when answering the prompts. So maybe we represent it like this. And the knowledge base is generated by, knowledge base is generated by web scraping. And here we can web scrape some local news sites. In Miami, local news, real estate agent blogs. So he kind of knows how real estate agent talks and how they should interact with clients, etc. And from that we can build our knowledge base. So basically we will periodically scrape this data, add that to a knowledge base, and feed that into the initial template that the LLM uses when answering all the prompts. And that's how you solve this. And you might be wondering, well, how does the LLM know when it should use Report Lab for the reporting feature or SQL database to retrieve property information? It's a good question. And that's why we're going to feed it. And this is the most important part of building this LangChain application, is the prompt template. Actually, no, the prefix template. This is just a huge string where we give it, human instructions on how to analyze it. So for example, we can say, if the prompt contains generate a report or something to that line, that's when you should use Report Lab. This is how you should use Report Lab. And then once you're done, and before you generate the reports, you should use the SQL database to get the properties for the report, etc. So the prefix template kind of brings everything together so that we can get the response. Another feature that would be useful to implement, which I forgot to talk about, is if the investor is interested in a certain building, well, maybe they want to get like a nice video of how the building looks like. So perhaps we could take the photos from Google Street View, which sometimes contain interior apartment photos as well, and we can create some AI slideshow from that. And from this, we would need to hit the Google Maps API again and get the photos and feed that to a video generation service, which will be an external API as well. All right, so here we have an outline of what we're going to be going through in the next coming videos. I know it can seem very overwhelming and a bit messy, but trust me, when you make these yourself, you'll really understand the power and the value that comes from having them, especially if you're working with teams, because your front-end team and the other teams, they can follow along exactly what it is you're doing without even having to read your code, which is insanely valuable. So I hope you start using this strategy as well, and it saves you on a lot of development time, as it has for me. In the next video, we're basically going to build Conda GPT from scratch, like a lot of you requested, following this template. Now, before I leave you, as promised, I want to share with you a free AI engineer roadmap that I think is very useful for you to learn the concepts you require to get an AI engineer job. So I'm going to leave this in the description, but you can follow along here, and on each node there are some resources. I guess some of them are premium and some of them are free on how to study each topic. But basically, if you can't find the resource here, you can just Google what is an AI engineer or what is inference in AI engineering. And I recommend you follow along with this roadmap because it is extremely useful stuff in here, and I think it's structured in a very nice way. Apart from that, if you're an existing software developer, I highly recommend getting some experience with a lot of data. So you can maybe look at data sets on Kaggle, run experiments or projects with them on your free time, or if they're in a data heavy project you can take on at your current job, I would do that as well. Basically, the more data experience you have will help you break into AI and machine learning because it is so data driven. And my final tip is try to niche yourself down to one industry. As you can tell by my videos, I'm very niched in real estate. It's an industry I know very well and I've worked for in a long time, and it just opens up so many doors when you have that expert knowledge of an industry like real estate technology, and it just helps you grow in your career a lot faster. That's it for this video. Thank you so much for watching. I hope it helped you out a lot and gave you a lot of value, and I'll see you later.